All right, so number 41 says, write the first trigonometric function in terms of the second for theta in the given quadrant. So we want to write tangent of theta in terms of cosine of theta, where theta is in quadrant 3. Okay, so the first idea here is noticing that tangent of theta is just sine over cosine. So we almost have everything in terms of cosine. We just need to change sine of theta into a form of cosine of theta. Recognizing our Pythagorean identity, sine squared theta plus cosine squared theta equals 1. If we solve for sine squared theta, we get sine squared theta equals 1 minus cosine squared theta. Taking the square root of both sides. Now remember, whenever we take the square root, we always get plus or minus. And this is a very important idea in our problem. Because what's going to help us determine whether it's the positive square root or the negative square root is where theta lies. So theta is in quadrant 3. So if we graph our coordinate plane, theta is in this quadrant here. Okay. All students take calculus. Quadrant 3 is when tangent is only positive. That means sine and cosine are both negative. So that tells us we're going to use the negative square root. So sine of theta equals negative square root of 1 minus cosine squared theta. So writing tangent theta in terms of cosine theta becomes negative square root of 1 minus cosine squared theta, all divided by cosine of theta. So just to recap of what we did, we changed tangent theta, okay? We wrote it in terms of cosine of theta, given which quadrant our theta lied in, okay? And we did that by using the definition of tangent, which is sine over cosine, as well as our Pythagorean identity.